think this is the last session in the room. So as Jim Collins said, we're going to finish strong. So I'm going to talk about leveraging AI for smarter decision making. I will say I had a conversation not too long ago. For those that don't know, on Tuesday we had a full AI workshop for the full day. You've heard about AI a lot. I think there's a little bit of AI fatigue I'm sensing. But I'm really happy to have all of you here. This is a topic that we can talk about all day. Love the topic, and so happy to share this with you today. My presentation is going to be, I think, a little different than some of the other AI presentations you've seen today. I'm going to talk a little bit about decision making, and the decision making and how humans and machines do that and how they work together and some of the advantages of each. And so one of the things I do want to start with, Andrew Ng, who's a very popular figure in the AI community, made quite a statement. Artificial intelligence is the new electricity. That's quite a statement. So he's saying electricity. Think about how electricity changed the world. It empowered the Industrial Revolution. It made it possible. It gave us electric engines, it gave us light, it gave us all of these things that we're able to do today. And he's predicting that artificial intelligence will be the thing that will empower the digital transformation, the digital revolution. And he's putting it on that same scale. It's quite an amazing thing. And so that's why we've been talking about it for all these days here. You've seen some of these stats. So Gartner talks about the importance of AI within the modern commerce, the digital commerce space, and they've made these quotes by these predictions by 2020 that 60% of all companies will be using AI technologies in their digital commerce, and 30% of the revenue growth associated with digital commerce will be coming from these AI technologies also. Now, I think you've probably seen some of these too, the success stories of pros and pros' customers in using AI. A lot of revenue lifts, great turnarounds, quote, turnaround times reduced by 80%, price recommendations that lead to millions and millions of dollars of revenue and margin improvements. I think you've heard a number of these stories this week. Pros is utilizing AI. We have tremendous success rate at that. And a lot of this centers around the transition from traditional commerce to this modern commerce. And this is something you've heard a lot about too. So this modern commerce is really associated with many things. And coming from the science and research department, I look at some of the science and algorithmic aspects of this and how it empowers these personalized offers. It powers these frictionless omni-channel experiences. But one of the things in this modern commerce I think that's really interesting is if there is this reliance on science, if there is this reliance of algorithms, what does that mean? Clearly it means that machines are going to start taking over at least some of these tasks. We've talked about automation. We've talked about guidance and recommendations. So we're putting more and more reliance on the machines, which can be a very good thing. However, we're also taking potentially some of that decision-making process away from the humans. And so what I'd actually like to talk about is that aspect, the decision-making process with humans and machines, and what does that look like? And where can we make improvements on the machines based on that context? And so let's start talking about humans. So Tetlock and Gartner, in their book Super Forecasting, have an extensive study of people and doing predictions. It's a study that spanned multiple decades, and they've started identifying what makes people good predictors and not so good predictors. And they have a very interesting book I would recommend called Super Forecasting. And they identify a number of different areas and characteristics of people that are good at prediction. And one of the things that they've also noticed is things about where people are commonly bad at prediction is what he calls the tip of your nose experience, or tip of your nose perspective. And so you can think of that almost literally. What does that mean? It means I'm making my predictions, my recommendations based on the things that are right in front of me, right? And this corresponds to things that we've commonly talked about in AI and science models, that science models are able to incorporate and consider vast amounts of data that people just cannot consume. And so this is a nice framework for that idea, that people have this tip of your nose experience or perspective. And this is one of the ways where I think we kind of jump onto these AI and we jump onto these science models to help alleviate this perspective and gain more perspective with more data and to make better recommendations. But the track record of AI isn't perfect either, right? These machines have their successes and they have their failures. And I've got some kind of fun and cute examples up here. So one of the successes, and we talked about this quite a bit on our AI workshop, is the game of Go. It's an ancient game. And so recently, DeepMind had AlphaGo, which developed an AI agent that didn't know anything about the game, didn't have even training by experts, used AI techniques to actually develop strategies that became so strong that it actually beat the best humans at the game of Go. There's also other successes that are of probably more interest to us, commercial successes of AI, right? The billions of dollars that have been generated based on AI recommending the right advertisement on websites, the numbers there are gigantic. And obviously, we saw a few slides ago the success of our pros customers in generating millions and millions of dollars. But let's talk a little bit about the failures. A cute example of a failure is Alexa. This is a true story. So a little girl, when Alexa first came out, ordered herself this giant doll house and a big box of cookies. So you can see the little box of cookies there. So it's a cute example. Mom and Dad came home and were quite surprised. And Amazon realized we needed to change a little bit about Alexa. But there's also some serious failures of AI also. And some of those are in the news. We have self-driving cars that have had accidents. They've misidentified signs, buses, things of that nature. And so there's some serious failures of AI. And so actually we had a session yesterday with Meet the Scientists. And there was a discussion about, well, why does an AI project fail? And one of the key aspects of why an AI project fails is there is such a hype around AI that people are jumping into this bandwagon. And sometimes they don't have a very clear business objective of what they're really even trying to achieve by implementing this technology. And so that is definitely one area. But we're all here, we all know objectives that we want to achieve. So I want to talk about some other reasons where AI projects can have some hindrances. And so essentially what I'd like to talk about is, if we go back to this tip of your nose perspective, we have this idea that AI can be applied, look at wide ranges of data, identify patterns that humans cannot, and we can achieve this superhuman level of performance. That's what we're all wanting. And there's reasons to believe that we can get there. However, if we look back, maybe we need to take a step back and say, we've had these failures. What if we think about achieving human level of performance? What does that look like? And so one of the things I want to talk about today are three different issues that I believe are commonly not addressed very well by AI applications, and why some of them have failures and some of these solutions don't gain as much traction as they should. The first one I'd like to talk about is multiple objectives. Actually yesterday, and it was a great session with Meet the Scientists. I hope you can come next year to it. There was a question about pricing strategies. Like, how can we use AI when our pricing strategies vary so much by markets, by product categories? How can this system adapt to that? Well, really, those strategies correspond to objectives. In the world of optimization, we talk about objectives. What is the objective that you're trying to achieve with this AI agent? And commonly, AI agents are very, very good at achieving an objective. However, when we get into the real world, a lot of times there's multiple objectives, and we're going to talk about that. The next is risk. A lot of times people have a very risk-adverse nature, and AI systems sometimes don't address that terribly well. And also the third one is humans' comfort with change. I think this may actually be the biggest one. And so let's talk about those in a little more detail and what those look like. So do we have any airline, car rental people in the audience? All right. So objectives. So obviously we have revenue management, so we're trying to maximize revenue. But load factor is also a very key consideration generally in the decisions that we make. For example, if you look at an airline's financial statements, you'll commonly see revenue performance, margin performance, and very closely behind that will be load factor or utilization. And why that's important is because that load factor utilization of their inventory is kind of a signal to the market of market share. So if I'm maximizing revenue, but my load factors are going down, it can be a signal that I'm losing market share. The future of my company is maybe going in a direction that isn't so great. Another one that's very common is profits and market shares. So we can set prices quite a bit higher, and we can probably get the customers that are willing to get that profit, are willing to pay that price. We can actually generate quite a bit of profit from that. But with that high price, we're going to be turning away a number of different customers, and then we're going to be losing market share, which again is another thing that is not desirable. So we have to consider both of these objectives, and these are just two examples. So actually, I'd like to have a little interactive part here in the presentation. So I'm freely admitting that I'm stealing this from Astro Teller. He's the CEO of X. X is a spin-off company of Google. It's a moonshot for moonshot projects. So if you can imagine that perspective, he comes at this problem a little differently. But he has this question, and I'm going to ask you what you think. You have two choices as an employee. So you can make one choice that I'm going to work on projects that I will contribute $1 million to my company. And it's certainty in that outcome. Okay? The next option B is I'm going to take on a task that has the potential to generate $1 billion for my company, but there's only a 1% chance that it actually happens. Okay? So the part of my question isn't a math question, so I'm going to give you a little bit more information. Many of you already have figured this out. So the expected return for choice A is $1 million. The expected return for choice B is actually $10 million. It's 10 times the amount of return for choice A. I'm not going to say that there's a right or wrong answer, but how many people think that we should do choice B? Okay. And now, to Astro's point, how many people think that they would let your boss do choice B? Nobody's raising their hands, right? Why is that? It's because there's a risk aversion. So what I have, and I have it on the slide here, so I kind of cheated here. So decisions are typically involved much more than just expected values. So imagine we put an AI agent that's rather naive, possibly, that looks at this problem. What choice is it going to say? It's probably very likely going to say choice B. Its expected outcome is 10 times larger than choice A. Now imagine what your boss is going to see when he sees that recommendation. It's probably not going to go over terribly well, right? So you can start seeing some of these conflicts. Now, obviously, this is a very extreme example, but I think it highlights this point of risk. And so it's been interesting. I appreciate the participation here. And so this audience, listening to Astro Teller do it in his audience, and then when I was reviewing some of this material with some colleagues, I saw 100% this very same behavior. And so is that just because I've got a sample of 100 people now or 50 people, or is there something more to this? So risk aversion is a very well-studied topic. And one thing I just wanted to bring up here is in 2002, Kahneman won the Nobel Prize in economics for what became prospect theory, something he developed with Stravinsky. And this is really about behavioral economics. And essentially what this is all about is decision-making relative to risk. And so what they found is that this is a little hard the chart I think does well, but actually people put less value on gaining a certain amount, say $100, than they do on losing $100, right? They're risk adverse. And if you had an outcome where you're flipping a coin, you have a 50-50 chance, it kind of explains why double or nothing really isn't a very popular game, right? The expectation is zero. You could imagine that there's 50% of people will be willing to do it, but it's not very popular. So risk aversion is something that is part of human nature. And so it's something that we need to take into account when we're building AI agents and making recommendations to people. All right, and now I probably think this is actually maybe the biggest one. And if you were in the previous presentation, the speaker was talking about this very thing, about change. So BJ Fogg is a behavioral scientist at Stanford, and he has a model that talks about people's behavioral change. And he has a very nice model for it, and I'm not going to go into it here. But essentially what he talks about is one of the ways to get people to make change is actually in mini baby steps. If you try to make big steps, it commonly won't have a change in behavior. It will fail. And so what we need to do is to have this idea of these many small steps towards this goal. Now, I think that the theory here is very nice, and actually one of the things yesterday when Jim Collins was talking about, he was talking about us being in a race. We're in a race whether we want to be or not, right? We're all going in this direction of modern commerce, of AI. I've had questions this week about how should I start, when should I start? Combine this idea that we're in a race and we're going in this direction. Combine that with this idea that we're only going to ever be willing to make small baby steps. We know where we're going. We're only going to be able to make small baby steps. I think the time to start is now. Because 2 years from now, you're not going to be wanting to make big steps then either. So start now, start small, and make these baby steps towards the completion of that race. All right, so let me see how I'm doing on time here. So now we've talked about these humans. Are they experts? Are they not? Well, it's kind of a mixed bag. They do have that tip of the nose perspective, which we've talked about not being so great. They potentially have this unwillingness to make big changes. So if we're in a position where we're not doing terribly well, we're probably not going to make huge changes to move to some glorious place. We're going to make small changes to get there. However, they also have some good things. They potentially can have additional data that they're aware of, that the system just doesn't even know, that they can infuse into this system and actually have the system make better recommendations. They can be more aware of these multiple objectives, and they can also have a better appreciation of risk, as we had in the example. So one of the things I want to talk about now is now that we have that framework and some of those ideas, I want to talk through some of Pros's research and some of the solutions that we have to try to address those issues. So one of the things we can talk about with multiple objectives is actually a very well-studied field in optimization, and I've got a very simple example here of revenue and load factor or utilization. And so essentially what we want to do in this case is we want to have as much revenue as we can, and we want to do essentially as much utilization as possible too. And there's different price points, different fare classes that we can make available, and we can get different performance from that. So if we're very far on the left, we're going to set prices very high. So if we set them very high, we're not going to get a lot of bookings, so our utilization is really low. And because we have this mix of very high fares but low bookings, the revenue is going to be moderate. If we're on the very far right side, our prices are generally too low in those cases. So we get a lot of bookings, but the prices are so low that the revenue performance isn't very good. And so we can get this curve of these different options that we have that we can do, and we can look at what is the performance of these over these different objectives. And actually, there's many ways of solving this problem, and one way you can do it is to form this efficient frontier, which the efficient frontier, if you can see the dots, I'm not sure, Justin, can you see the dots back there? Essentially, the efficient frontier, which is essentially the options that you should consider that are they kind of dominate the other sets. In other words, they're the best options that you have considering these two different objectives. The efficient frontier in this case would be the three dots on the left, or on the right rather. So essentially the ones that correspond to the 90, 95, and 99% utilization. And so from there, then you get into this issue of how do I weight the different objectives, the utilization and revenue, to pick which of those actions that I want to take and put into the marketplace. Okay, another one I want to talk about is the idea of risk mitigation and small incremental changes, these baby steps. And so do we have any customers that have segmentation pricing guidance? Yes, great. So you've seen this chart on the left, and I'll describe it briefly. This is essentially what we have in our pricing solution is we'll do segmentation, which is actually taking our customers, the products, putting those things together into a segmentation process to try to identify customers and products that have this similar willingness to pay. And so then when we zoom into one of these segments, we can start looking at what are the transactions. So those dots are supposed to represent transactions within this segment. Then we have a pricing guidance process that identifies what is the recommended price that I would charge for this segment. And that's represented by the target price. Now, when we do this, we're going to start identifying what we call underperformers. Transactions, customers that are paying under that target price. So some of those could be pretty severe underperformers. So what should we do? Should we take that underperformer and overnight raise their price 20%? Do you think we should? How many would want to do that? One would. Good, good, which is another very good point here. One of the things that we've seen in segmentation pricing guidance is generally the unwillingness to do this. And so what had happened in our previous generations of our application is people would have to set up business rules and say, okay, guidance is saying I need to increase 20%. I don't want to do that. Now I'm going to have to put a business rule that will limit the amount of increase that I give them. However, we've seen that so often that we started looking at using machine learning to actually, can I actually predict and give a step size, if you will, of how much that increase should be. And that machine learning is looking at the company's willingness to increase that much, and actually the feedback that we get from the customers. Actually, do these transactions take place? And so the one thing that's really nice is some people are willing to take a little bit more risk. And so this can actually identify your willingness to take risk, your willingness to take that step, and can adjust and make guidance more appropriate for you. Yeah.
We go back to the little point on that. If I have to raise it by 20%, doing it slowly, monitoring, finding the right moment, implementing, monitoring, finding the right moment, continuous evolution of that will be more expensive and cumbersome than just raising by 20% and seeing if it does. And if it does, I get to the guidance was correct, and it gets to where I wanted to. And if it doesn't, I very quickly know that it doesn't work, and then the guidance was incorrect. Even 3 months later, it would be still correct because that segment of the market at that specific time is not willing to accept a 20% increase. Maybe you will in 3 months, but to get to 3 months at like 0.01, 0.05, 0.1%.
Yeah, there would have to be a realization of that step size. 0.5% increases, you're going to have salespeople that are going to think that's not even worth their time to actually go have those conversations. So there does have to be the appropriate step size, I'll say. And yeah, there is an idea, and we'll get to it in the next example of, if we think of this as a generic lab environment, maybe increasing by 5 or 7.5% isn't in a lab environment, may not be the optimal solution. But in the example that you get the 20% and it actually happens, well, that's great. But what if it doesn't, right?
I would rather spend the resources in finding that ideal number, whether it's 20 or 50 or whatever, like calculation, than slowly raising and seeing how it works.
Yeah. I think this gets to the point of, if you will, personalization. So we've talked about personalization to the customer. I think there's personalization to the company that are doing these processes. If you want to take on more of this risk, if you want to take bigger steps, that is something that the system can learn and adapt to your desires. Yep. All right, another example that I have is setting these price recommendations in a e-commerce portal environment. So now we're going from pricing guidance where we have negotiations, where salespeople are using that guidance to actually set the pricing, to putting a price on an e-commerce portal. Now, in that case, there's no envelope, there's no floor target expert to negotiate for a salesperson to tailor to this exact situation. So we're asking the machine to do quite a bit more here. So the sensitivity of this is actually, I would say, greater. And so we need to consider these risk mitigation, these baby steps, even more in this case. And so we developed this process to determine what this optimal price should be. And so essentially what it's doing is defining estimating a demand price response model. And so how much demand would I get at different price points within this segment? From that, we can get an expected profit curve that's being shown here in the green. But along the way, we've actually estimated confidence intervals. What do I think the confidence is in this model? And so we can look at that green curve, that expected profit curve, and we can say the optimal price to charge in this case would be $50. that is going to generate the most profit for me. However, you'll also notice there's a rather large confidence interval around that, which is saying I'm not really certain about the pricing at that point. And so can I actually take that confidence level, that recommended optimal price, and then also kind of this reference point of where pricing has been in the past, and can I now move towards that optimal price in a step size that's relative to the confidence, and is starting from this reference point that people are comfortable with. And actually, this actually has nice convergence properties also, as far as this will get to the optimal point under reasonable assumptions. And we actually had the opportunity to apply this model to a customer's data set. And so we worked with them, and we got an estimated 200 basis points margin lift using this approach, and that's with just the first step. And most of the price, the vast majority of the price changes in that scenario are within 3%. And so there's a lot of benefit by this very precise pricing, but reducing the risk and reducing the amount of change that's going to have to be absorbed at this first step. Yeah.
Does the model take into consideration when you're quoting something lost, or get market intelligence on from the sales team, we lost 5% or 10%?
The model, that is actually something we're working on right now. So in the vast majority of the cases, we actually don't have that information. So we first wanted to create this model without having that data available. But there are cases where we do have that data. And so that can be easily incorporated into this process to generate those demand estimates. And so that's something we're working on right now, actually. All right, so I want to get into another thing. And so we've talked about the humans, and we've talked about their behaviors. And so one of the things that we've done, if you heard Justin talk earlier today about opportunity detection, you heard him talk a little bit about this. So in opportunity detection, we're offering opportunities to salespeople. And so that can be cross-sell opportunities, maybe products that a customer has not been purchasing recently. And so with those opportunities, we also give the analyst the ability, the salesperson the ability to actually accept or reject these opportunities. And so we can now gather that information from the user. And what we wanted to do is actually to develop a machine learning model. Can we actually predict if they're going to accept or reject? And actually, we started trying that, and we actually had very good results. We could actually predict quite well if they were going to accept or reject these opportunities. And so in these cases, it gives us an opportunity to now feed that information back into our opportunity recommendations. And so the recommendations that the system will put forward moving from that point forward are actually more in line, they're more personalized to that user, to that salesperson. Okay. Another one that I feel is quite interesting is, again, trying to look at the behavior of the people themselves. In our revenue management systems, we commonly will forecast the number of bookings, the demand that's going to happen for these flights. And so with those forecasts, we actually give the analyst the ability to influence what that demand estimates will be. So I believe my Houston to New York on Saturday is actually going to be 20% more than what the system suggests. We give them that functionality. And so, again, similar to the last use case, is actually could we start applying a machine learning model to actually predict what these analysts are going to influence and how they're going to influence these markets? And actually, we took a carrier's data. We chose 10 international airports. It consisted of 76 O&Ds, about 1/6 of the demand for that airline. And it was a very nice representation sample of their data. It had short haul, long haul, domestic, international markets. And actually, we could apply machine learning, and we could actually predict these influences within 5% mean absolute percentage error. So that influence, we were able to predict very finely and very accurately what these analysts were thinking. Was there a question?
Actually, it's a very good idea. But, I suspect if all the analyst influences are 100% correct, so we have experienced users, but we have new joiners as well.
Yep.
So we, is it a, I mean, good idea to make the machine learning
Yeah.
for the
That was not a planned question, but it segues nice into the next thing. So the next thing we looked at is, did these influences actually help? Do I have a new analyst that maybe isn't providing the best influences into the system? And actually, we saw that some of the influences did help. They did improve forecast accuracy, but actually, more of them actually hurt forecast accuracy, which was kind of interesting. Another thing that was really interesting was looking at the machine learning models that were accurately predicting those influences, and what were the data features that the model was using and leveraging to actually get that good prediction. And actually what it suggests is that the analysts were thinking about their forecast in a year-over-year manner. And year-over-year forecasting can be a good approach, but generally for the level of granularity that we're forecasting at, it's generally not a good forecast method. And so potentially this becomes a coachable moment. Potentially these models can actually, and some of these metrics, can start saying, hey, RM analyst manager, you may want to talk to this analyst about what these influences that they're doing, that they're harming the accuracy of the forecast. And it can actually even point to ideas of how that RM analyst is thinking about this market and how they're trying to change the forecast. So it's kind of interesting in the fact of this coachable moment, but I kind of go back to this, which we need to think about more, is year-over-year forecasting, although in an environment where you have a lot of sparsity, where you have a lot of volatility, year-over-year is not a very good approach. I mean, if you think of it from like a machine learning aspects, it's incredibly susceptible to overfitting. And so essentially, one of the things that we get from it is this idea that is there other reasons why they're thinking about it? One thing that is about year-over-year forecasting is it's very easy to understand. It's very easy to relate to. And so is it actually point to this idea that maybe the users aren't ready to make this big step? So I think that's a human aspect, kind of a change management aspect that I think is quite interesting in this application. I would actually love to get your feedback on that. And so now I'm going to just wrap up here. So what have we talked about? We've talked about leveraging AI to make smarter decisions. We've talked about the differences between how humans and the strengths that humans and machines have in making some of these decisions. Three of the common things that we talked about today that humans sometimes can have over more naive AI methods is this idea of multiple objectives, the idea of risk aversion, and this willingness for only small changes. Eventually, any of these recommendations are going to have to go under some scrutiny of some human. So these human behaviors are not going away. And so we've talked about how Pros is looking at AI, how we're researching these things to actually address some of these issues, such that these systems that we're producing not only give lots of great value, but they drive adoption and they minimize risk. and they fit in this environment and this human behavior models that we've seen. And so with that, I will take any questions.
Thank you very much, Royce. That was fantastic. Okay, I do have a few questions for you, or the audience does. Given that AI systems are designed by humans, how do we protect against the potential biases that can be put into the system?
So one of the things that we deal with, I believe the question is, essentially, so I have AI models that are typically modeling history. And sometimes the concern is that, well, in history, I wasn't doing the perfect thing. So am I modeling something that wasn't perfect? So hopefully that's the question. That's the situation. So one of the things that I think about in that environment, and I'll use, it seems like segmentation pricing guidance is maybe the more popular thing here. In segmentation pricing guidance, we're forming segments that is looking back at historical transactions. So we are actually incorporating some of that prior behavior. That is true. Now, the one thing I will say from that is when we have those segments, now we have this framework to start looking at, well, what's kind of the best decisions within this segment, within this group? And now we can start making better decisions within this group. And so the thing is when you switch the system on day one, you're actually going to get improvements based on that process. You're looking at what are the best decisions within this group, even if the group isn't perfectly defined. But then we're actually getting those recommendations out into the marketplace. We're getting feedback loops into what is the response of the marketplace to those prices. And now these segments have the ability to now adjust. So day one, you get value, and that value actually increases over time as it learns and grows.
Wow, interesting. Okay, I have another question for you. This is an interesting one. We seem to have far less tolerance for when AIs fail than when we do when people make bad decisions. For example, the news around the self-driving cars that crash.
Yeah.
How do we overcome that lack of tolerance for AI mistakes? Yeah, okay.
The system worked exactly as developed.
Right.
So let me answer your question. So I think it goes to some of these points, right? I think we have to realize we are going to be very reluctant to turn things over to machines. That gets to that big change part. So I think it's a matter of making these systems such that they're addressing risk. They are aware of this small changes that are needed. Maybe we get into an environment. Maybe it's okay with pricing guidance if I'm not jumping from the $100 I've always been pricing to the $150. Maybe even if there's evidence that $150 is actually probably a pretty good price. But the adoption of that system could be very difficult. And so what we've seen and what some of these theories would suggest is that we need to make these baby steps. We need to get the systems reducing that risk and then providing value, getting feedback, having those success, and then making another step.
Okay. So on that note, AI has developed a lot over the recent years. Do you expect the rate of development of AI capabilities to stay the same or accelerate?
Wow. That's a good question. Yeah. Michael's saying that they're going to go up. I would definitely agree.
Yeah.
They're growing at such a rate. There's such an emphasis on it. It's really a combination of things about the actual mathematics of it, if you will, that are growing significantly. There's a computing power. Andres was talking about this. The computing power is growing so substantially too, and the availability of data. So you combine those things, and AI is the new electricity.
Absolutely. Wow. It's fascinating. Everybody, Royce Kallesen. Oh, we have another question. Oh, yeah, sorry.
Can I quick comment on your slide with the little girl and the
Yeah, sure.
I would actually reverse and say that was a failure. So people obviously AlphaGo would never know or understand the curve. It was just about winning. If it's about winning, any machine can beat a human. They can compute millions more possibilities in a very short time. But Amazon Echo was created for the purpose of a more efficient and effective ordering. In this case, the girl proved that it was very efficient to order.
Right?
I guess it's a matter of perspective, huh? From the girl, it was a big win. Although I think they did actually send it back, if I remember the story right. I don't remember.
But that was a great presentation.
Yes,
Oh,
it was.
thank you.
Any other questions? All right. Royce, thank you so much. And thank
Thank
everybody
you.
for attending. Thank you.